Innovative semiconductor in quantum computing. Before we talk about this semiconductor, let us first know what is quantum computing.
In modern computers, data is stored through bits. These bits have two states, on or off, but it can only be in one of these states. In quantum computing, bits are stored through qubits or quantum bits. These quantum bits, unlike bits, have a probability to be in any one of these states.
So what are semiconductors?
According to Oxford, semiconductors are a solid substance that has conductivity between that of an insulator and that of most metals, either due to the addition of an impurity or because of temperature effects.
What is the connection between quantum computing and semiconductors?
There are three main ways in which semiconductors are related to quantum computing systems. These are heterostructures, SRT-embedded heterostructures, and quantum dot arrays. The heterostructures consist of different semiconducting layers which have the same elemental composition, but with varying elemental ratios so that the properties of each layer is slightly different.
The SRT-embedded heterostructure forms a CNOT gate which enables a more precise control of the interactions between the qubits, and then removes the need for multiple gates on the surface of the heterostructure.
The dot arrays are electrostatically defined. Semiconducting quantum dots can be used to lower the electron tunneling barrier when two qubit couple. Innovative semiconductors materials for quantum computing.
Graphene has always been a material that has a lot of potential in the computer scene because of its properties, like its conductivity. In quantum computing, physicists created a graphene structure that enables single photons to interact with each other, which makes it a promising material to use in storing information in quantum computing.
Now we move on to oxide semiconductor. So what is oxide semiconductor?
Oxide semiconductor is also a new material being tested as a semiconductor, and the results show that electrospin quantum bits in SI are promising because of long disk coherence times negative 0.5 ms, but electrical gating schemes still seem problematic.